In this example, we're going to walk through and find the exact value for the tangent of 6 degrees, and we're going to do so by using the difference identity for tangent. So we have two angles, A and B, and it will have this expression here. It's a fraction. And we're also going to employ this tangent of 36 degrees, which this radical expression right here we found from scratch in another video. And so that tangent of 36 exact value video has been linked down in the description for this video. So let's go ahead and get started. So we need two angles, A and B, that when we subtract them, we get 6 degrees. And also A and B need to be nice values that we know the tangent. Well, that's why I've included this tangent of 36, because we didn't know that off the top of our head, I can't imagine. So let's go ahead and say that we're going to use 36 degrees and 30 degrees. And 30 degrees is a nice angle that we know the tangent for. Okay, so this expansion is going to be the tangent of the first one, so 36 degrees, minus the tangent of that second one, 30 degrees, all over 1 plus, and it's going to be the product of these two. So the tangent of 36 times the tangent of 30. So this is what this expression is going to look like. So let's go ahead and start plugging in values. And I will warn you ahead of time, this is going to be a very intensive process that's going to have a lot of numeric simplification involved. We'll have to end up rationalizing the denominator multiple times. But I really want the final product, or this final expression, to be as succinct and nice and tidy as possible. So just a warning, here we go. So the tangent of 36 degrees is this radical expression right here. And we're going to subtract from that the tangent of 30, which is the square root of 3 over 3. And in the denominator, it'll be 1 plus, and then of course the product of these two. So let's go ahead and start with radical 3 over 3, and then multiply it by this radical expression. So here what you see is the exact value for the tangent of 6 degrees. It's just not very nice looking. So we're going to try to see if we can tidy this up quite a bit. Okay, so let's start by getting common denominators in this numerator and this denominator. And when we do so, we'll multiply this by 3 over 3 and this by 3 over 3. So we'll have this first one minus the square root of 3 all over 3, that common denominator. And all of that then is over 3 plus the square root of 3 times that radical expression. And that's over 3 as well. Okay, these complex fractions, when we go ahead and do this division, we're going to be multiplying by the reciprocal here, so it'll be 3 over. And what you'll see are these 3's are going to cancel, and this will be the numerator, and this will be the denominator. So let's go ahead and write it that way. So we have 3 times that radical expression, and you'll see everything is just going to get copied down right here, a little cleaner. Okay, so you see we have a fraction, we have irrational numbers here, numerator and denominator. So let's go ahead and do our first rationalization. So we're going to rationalize this denominator by multiplying the top and bottom by the conjugate. So we're going to multiply by 3 minus the square root of 3. And then we have, of course, this square root expression. So we'll just copy that down twice and then multiply it all out. So let's get parentheses around everything so we can kind of keep all this multiplication straight and see what this is going to look like. Okay, so 3 gives us a 9 right there, 3 times 3, and then this radical expression will come along for the ride, and then we'll multiply it this way, so it'll be minus 3 radical 3, and then since these two radicals are being multiplied and they're the same radicand, the square roots will cancel and just leave me with a real 5 minus 2 radical 5. And then let's do this distribution as well. So minus 3 radical 3, and then plus 3 times, and then of course this radical expression. And our denominator is going to be this difference of squares factorization. We'll multiply it out. So we'll square the first one for 9, and then minus, and then square this second one as well. All right, so that's what we have. So let's clean this up a bit. We'll do some distribution here and combine like terms and just see what it is that we're dealing with. All right, so minus 15 radical 3 plus 6 radical 15 minus 3 radical 3 plus 3 times that radical expression. That's our numerator, and our denominator looks like 9 minus 15 plus 6 radical 5. Okay, lots of like terms here. Let's go ahead and start with this 6 radical 15. That's that guy, and then radical 3 is negative 15, negative 3, so negative 18 radical 3, and then 9 and 3 is going to be a positive 12 for that rational expression right there, or that radical expression rather. And 9 minus 15 is negative 6, but we'll put this positive one first. Okay, so it's looking a little cleaner. And actually it's nice because all of these numbers are multiples of 6, so we'll divide 6 out of everything. Okay, so what we have then, let's leave it right here I guess. So the square root of 15 minus 3 radical 3 plus 2 times that radical expression all over the square root of 5 minus 1. Okay, well, we still have a fraction and we still have an irrational number in the denominator. So let's go through and rationalize this one more time. So we'll multiply the top and bottom by the conjugate, which will be the square root of 5 plus 1. And once again, make sure to get all these parentheses around here really nice like. Okay, so let's do all the multiplication here. So square root of 15 times the square root of 5 will be 5 radical 3 plus the square root of 15 minus 3 radical 15 minus 3 radical 3. And then I'm going to do something here. I'm going to go ahead and distribute the 2 through here, but leave this separate. So this is what this is going to look like. 2 radical 5 plus 2. And then times that radical expression. And I'll show you why here in a moment, why we're going to do that. Okie dokie. So when we go ahead and multiply here, we get 5 minus 1, which is 4. And that's pretty nice. Okay, once again, some like terms we can go ahead and put together. So 5 radical 3 minus 3 radical 3 will be 2 radical 3. And 15 here, and 15, so 1 minus 3 is negative 2 radical 15. And actually, let's bring that 2 out because we're going to do something here with it. So the square root of 5 plus 1, and then multiplied by this radical expression all over 4. So you'll notice here, once again, all of these have a common factor. So we'll divide and cancel a 2 out of everything. And this 2 will bring out as a 1/2 out front. So 1/2. Okay. And we have looks like these two, and then this guy over here. So let's factor a square root of 3 out right here. So we have 1 minus the square root of 5. And then, okay, so what can we do here? Let's go ahead and actually put this guy inside the square root. And you're asking, well, that doesn't seem very simplified if we do that. But let me show you what this is going to look like. So when we put something inside the radical, we need to square it. So we'll have the square root of 5 plus 1 squared multiplied by that 5 minus 2 radical 5. All of that is under this radical here. So let's focus on this for a second. And I'll do it in blue, that way we can kind of keep everything separate. Okay, so when we square this little binomial guy, it's going to be a squared plus b squared. So 5 plus 1 is 6, and then plus 2 radical 5. And we'll multiply it by this guy here. All that's under that radical still. So it looks like 30 minus 12 radical 5 plus 10 radical 5 minus 20. Interesting. So looks like 10 minus 2 radical 5. All that's under the radical. And then let's just take the 2 out. So we have the square root of 2 times the square root of 5 minus radical 5. Okay, and I'll show you why we're going to do that here as well. So what we have here now is plus the square root of 2 times that square root of 5 minus radical 5. Okay, change back to my original color here. All right, so here's what we can do. This square root of 3 can go over 2, so 1 minus the square root of 5, plus the square root of 2 over 2 times that radical expression. And I'd say that's about as simplified as we're going to get. That is pretty tidy, especially when you consider all the steps we went through and where we started. That is not very pretty up there. But this is nice. So this is going to be the exact value for the tangent of 6 degrees. But of course, don't take my word for it. Let's go ahead and grab a calculator and make sure. Okay, have our calculator here. So let's go ahead and move this up a little bit so we can still see this. All right, so we're going to use, let's see, the inverse of tangent, and we're just going to go ahead and put this expression in. So we're going to start out with this square root of 3 divided by 2, and that's being multiplied by 1 minus the square root of 5. And to that, we're going to add the square root of 2 divided by 2, and then multiply that rascal by 5 minus the square root of 5. Get out of all that, close those parentheses off. Yeah, look at that, 6 degrees. Okie dokie. So what that says then is this is the exact value for the tangent of 6 degrees. So we started up here. We did need to include this value for the tangent of 36 degrees. And once again, we found this from scratch in another video, and I've linked to that video in the description for this video. And so we use the difference identity for tangent. We use 36 degrees and 30 degrees. We had our nice expansion here, and then we worked out all that business. And so here we have the exact value, pretty simplified here, and this is the tangent of 6 degrees.